A heavy rock is blown straight up by a dynamite blast. The velocity of the rock at any time during its motion is v of t equals 160 minus 32 t feet per second. The rock was 256 feet above the ground 2 seconds after the explosion. Continue upwards to reach the maximum height of 400 feet at 5 seconds after the explosion, and then fell back down to reach the height 256 feet again at t equals 8 seconds after the explosion. Find the displacement and the distance traveled during the first 8 seconds. We're given the velocity function, so we can sketch the graph of the velocity. This is the graph of the velocity, not the position function. This is the graph of v against t. When time is 0, the velocity is 160. If we take 160 minus 32t and set it equal to 0, we see that t equals 5. This is the linear functions. With these 2 points, we can sketch the graph, which is a line. And we only need to graph it from t equals 0 to t equals 8. When t equals 8, we see that the velocity is negative 96. Plug 8 into the velocity function. The distance is the velocity times the time. And so from 0 to 5, since the velocity is positive, we would end up with an upward distance. And to find that distance, we just simply find the area of this triangle. This triangle has an area of 1/2, the base is 5, and the height is 160. And so this is 400. From 5 to 8, this area represents the distance going down, and the area of this triangle is 1/2 times the base. From 5 to 8, the base is 3 and the height is 96, and this is 144. And so we assume that when t equals 0, the rock is on the ground level, and when t equals 2, the rock is 256 feet above the ground level, and when t equals 5, that is when it reaches its maximum, and then it falls down after. And we're also told that when it falls down 8 seconds after the explosion, the height of the rock is the same as the height when it is 2 seconds after the explosion. And again, the maximum is 5 seconds after the explosion. From this, we see that from 0 to 5, the above graph gives us the area, which is the distance upward, and from 5 to 8, it gives us the area, which is the distance downward. The displacement during the first 8 seconds is 400 minus 144, distance upward minus the distance downward, and this is 256, as it should be, because we were told that when t equals 8, the height is 256. As you go from the height of 0 to the height of 256, the displacement is 256 and the unit is feet. Now, the distance traveled is not 256. We see that it goes up and then go down. The distance traveled is this area here. And so it is 400 plus the absolute value of negative 144 if we think of it at the area below the x-axis. And so this is 400 plus 144, which is 544. And so the rock has traveled a distance, meaning the length of the curve is 544. Its displacement is 256 feet.